A very warm welcome to all of you. In this lecture number 5, we are going to cover some important points from the chapter Nuclear Chemistry. The topics which we are going to cover in this lecture are measurement of radioactivity, different devices for radioactivity measurement, and the third important topic which we are going to study is applications of radioactive isotopes. First of all, we are going to study here the measurement of radioactivity. We know very well what is in by radioactivity, what are the different types of the radioactivity. Now, as far as the radioactivity is to be considered, how to measure this radioactivity? So this radioactivity can be measured with the help of certain devices. These are three important devices are commonly used for measurement of the radioactivity, like ionization chamber, proportional counters, and Jitter counters. Now let us look towards all these three types one by one. The first important type or the of device for measurement of radioactivity is ionization chamber. This device is based on the saturation current of region second from the graph of logarithm of pulse size versus applied voltage. If we take into consideration this graph of logarithm of pulse size versus applied voltage, in that graph the region number second is there. So this device is based on the saturation current from this region number second. There are two broad classes of this ionization chamber as non-integrating type and the second is a integrating type. These two classes differs in terms of response time relative to frequency of arrival of the ionizing particle. So in a short, we can say that this ionization chamber is useful for the determination or for the measurement of radioactivity. This device is based on a saturation current of region second. The second important type of the device is proportional counters. This device is based on the region third, that is proportional region from the graph of logarithm of pulse size versus applied voltage. So again we take into consideration the region third from the graph of logarithm of pulse size versus applied voltage. An argon methane mixture flows at atmospheric pressure through the counter at a rate of 200 ml per minute. From this device, that is a proportional counter, a mixture of argon methane flows at atmospheric pressure. These counters are useful for counting at extremely high counting rates, 50,000 to 2 lakhs counts per second. So if you want to count at extremely high rates, then these proportional counters are commonly used. These are useful for alpha particle counting due to its high ionizing power. So this is a very much useful for counting for alpha particles. The third important type of a device for measurement of radioactivity is Jitter counters. This device is based on a region fifth from the graph of logarithm of pulse size versus applied voltage. The current in this region is independent of the number of ion pairs formed in the primary process. Now, in this Jitter counter, some terminologies are used. First one is a date time of counter. Now, what is this date time of the counter? The period of time after registering the ionization event during which the counter is not in a position to register another such event is called date time of the counter. So we can say that if if we take into consideration the time required for registering the ionization event, so what happens at a single time this counter register a given event. During such a type of the registering the ionization event, it is not give the response for the registration for the another such event. So this time is called as the dead time of the counter. The next important concept from this Jitter counter is a Jitter plate. The range of voltage over which the pulse rate is independent of the applied voltage is Jitter plate. So the range of the voltage over which the pulse rate is independent of the applied voltage. So at that situation, it is called as the Jitter plate. So these are the three important types of the counters, or we can say the devices for the measurement of the radioactivity. After studying In a short, these different devices for the measurement of the radioactivity. The next topic which we are going to study here is applications of radioisotopes. As far as these radioisotopes are to be considered, these radioisotopes have a different type of the applications in different areas. So what are that important applications? So let us look towards that applications in a brief. Radioisotopes of elements have following important applications. The first important applications of radioisotopes is tracer in studying reaction mechanism. So this is the most important application of these radioisotopes for the determination of the reaction mechanism. If we want to study detail the mechanism of any chemical reaction, so for this purpose we have to use some tracer elements for finding out the reaction mechanism. So first of all, the element which is labeled is called as the tracer element. So in a reaction, if we label a particular element, then that element is called as the tracer element. This tracer element is useful in studying the reaction mechanism. So for considering this reaction mechanism, what is use of this tracer? So let us look towards a simple type of the reaction, that is esterification reaction. So we take here 1 mole of acetic acid plus 1 mole of this methyl alcohol. So by the reaction between this acid and alcohol, we get here ester, that is methyl acetate plus H2O. Now, as far as the formation of this water is considered, in formation of water, whether OH from acid and H from alcohol or OH from alcohol and H from acid are used, that is the question. So, as far as the way of formation of this H2O is to be considered, it has the two type of the different options. One option is that OH from the acid and H from the alcohol is to be utilized, or either OH from the alcohol and H from the acid is to be utilized. So to give the supportive answer to this particular question, we have to use here a tracer technique. So for this purpose, oxygen from the alcohol is labeled using O18. Means we have to take here a alcohol, such a alcohol in which this oxygen having, or it is a labeled oxygen is there. We take here isotope of oxygen with mass number 18. Now, when we use such a type of the labeled oxygen in this alcohol, then what happens? No labeled oxygen is found in water. This indicates that OH from acid and H from alcohol must have been utilized for water formation. So if we label this oxygen in alcohol and if we take into consideration the product formation from these two reactants, then what happens? The labeled oxygen is present in ester but not in this water molecule. So from this we can say that the OH from this type of the acid is to be given and the H from this alcohol is to be given for the formation of the water molecule. So this type of the important evidences we get from these type of the tracer elements or this tracer technique in order to study the reaction mechanism. So this is the first important applications of the radioisotopes. The second important application of this radioisotopes is in a age determination. If we want to find out the age of a particular sample, then at that time the different radioisotopes are to be used. So there are the different type of the samples depending upon a different type of the radioisotopes are to be used. So let us look towards one by one. First is the age of water sample. If we want to find out what is the age of a particular water or what is the age of that particular liquid, so at that situation we use here isotope of tritium, that is the isotope of the hydrogen with mass number 3. If we want to find out age of the dead organism, at that time we use here a carbon 14 isotopes which is called as the C14 dating. If we want to find out age of the minerals and rocks, so at that time the isotopes of lead may be used. It may be the isotope of lead with mass number 206, lead with mass number 207 and lead with mass number 208 may be used. And if we want to find out the age of the earth, so at that time we use here again the isotope of the lead but with the mass number 204. So we can say that these are the different isotopes, radioisotopes, and their respective applications in terms of the age determination. The third is nothing but the medical applications of the radioisotopes. As far as these radioisotopes are to be concerned, they have a very much dominant applications in the field of medical. So they have a very close relation to the human being because they are directly related to the medical facilities which we get nowadays. So here are some radioisotopes and their use. So first we have to look towards the purpose of study and which type of radioisotopes is to be used. So first one is mechanism of bone fracture healing. If we want to find out or if we want to locate the bone fracture healing in the body, at that time the radioisotope of sulfur with mass number 35, or we may use here radioisotope of phosphorus with mass number 32. For bone imaging, we may use here isotope of the fluorine with mass number 18 or isotope of strontium with the mass number 85. In a same way, if we want to study cerebrospinal fluid, at that time we use here the isotope of indium. For kidney disorder, we use here isotope of technetium and iodine. For liver and spleen, we may use here the isotopes of the technetium, iodine and gold. For lung ventilation, we may use here the isotope of the gallium and iodine. For blood disorder like leukemia, we use here radioisotope of the phosphorus with mass number 32. For function of vitamin B12, we use here the radioisotope of cobalt with mass number 58. And for metabolism process, we may use here the radioisotope of sodium with mass number 24, and we may use here radioisotope of potassium with mass number 42. So in a short, we can say that these are the different applications of these radioisotopes as far as the medical field is to be considered for the different medical purpose or for different study under this medical is to be considered. So these are the different applications of radioisotopes. For these radioisotopes, we use here the different studies, and for this different study we can use the concept of radioactivity shown by this particular radioisotopes. So in this lecture we focus on the different important topics. The first one is how to measure the radioactivity, what are the different devices for measuring this radioactivity. In the second half we studied here what are the different applications of this radioactivity isotopes with the different examples of these radioisotopes. So with this I stop here. The remaining portion from this chapter we will take in a next lecture. So thank you so much.